Hello, I'm Huldar and welcome. I'm gonna look at how to do a program that counts how often a button is pushed on the SAM D21 processor on the Arduino MKR NB 1500. So, if we go through this real quick. Firstly, I have a couple of libraries that I've made that I'm using. The register library is just for, maybe it's better to show you here. The register library is just for register manipulation, like to read it and to write registers. This blinker library has actually been super useful. That one is, I have some blinking signals, a success, a fail, blink a number of times, blink a heartbeat, and the success signal is half a heartbeat signal. And I can blink numbers. So instead of blinking number of times, you can blink number of times for the decimal and then number of times for the unit. The pointers is the biggest one I've been making, and it has pointers to a bunch of different registers in the memory. And so let's get into the function. On the Arduino, this blinking LED here, you can see this, can you see this? Yeah. This blinking LED here, this one is the pin on pin 20, and the button I'm using is on pin 21, which is right here in the corner. And if you want to be able to find out what the button pin is, you can just Google the name of the board and then add the word pinout, and you can find out, hey, here pin A21, it's this pin. So we have that. First we set the LED pin as output and blink a heartbeat, and you can see that if we, I'll go through it later, blink a heartbeat, and then we have to enable the input buffer of the input pin. That took me a while to figure out, but it is here in the datasheet. I love this datasheet, it's great. There are some things in the datasheet that are weird, like for example here in 21.7, they have external interrupt 7 and 15, 7, 15, 7, 15, but then they have 7 and 7 again here in the config. It's a little bit weird, but I think they will fix it. I emailed them about it. Here in the pin config, you see it here, then we have this enable register. And what it does is it enables the input of the pin. So here if it's 0, the input buffer is disabled and the input value will not be sampled. If it's 1, the input buffer is enabled and the input value will be sampled when required. So regardless of what the data direction says, if it's input or output, doesn't matter. If the input buffer is if the input buffer is not enabled, then nothing will happen. So we have to enable the input buffer. And then we make an empty counter because we have to count how many times the button is pushed. And then we go into the loop. Now the loop is very simple. If the button is pressed, then we increment the counter and then we blink whatever the counter is. And we can show you that this is actually what's going on. If we double tap the reset button, you can see it's fading in and out, so it's in bootloader mode. And then we upload the program. And it's uploading. So I have this wire connected here, and I'm just going to connect it to the ground right now. So it's connected to ground. And what we say is if the register is read as 1, that means it's high, the logical high, then we increment the counter. So if it's grounded, it should be low. Okay, so now it's blinking a lot. Let's restart it. So it blinks the heartbeat. It blinked here 0, 0, and then it strobes because it's finished blinking the number. So maybe I should show you this. Actually, what this does is it blinks a success and then blinks the digit, blinks a success and then the digit, and then it blinks a strobe. That's how this one works. So So here we are just blinking a strobe at the end, and then we get a success blink, no number, success blink, no number, so the counter is 0. Now if we take the button, this could be a button, you would have to hold the button for a long time for this to work in reality, but this is just for testing purposes. So if we take the button and we attach it to the volt, then we drive it to a logical high. So now we restart, it should blink 0 and then 1. So the button is 1 now. And then when we go again, it should go to 2. So now it goes 1, 2, and it strobes. And it can go to the third one. And it goes 1, 2, 3, and strobes. And if we take it and connect it to the ground while it is messing around, we get it 1, 2, 3, 4. Okay, I was not fast enough. So it should stay at 4 now. Let's see. 1, 2, 3, 4. And it did not go to 5. So now it's stuck at 4. I left this running for a while and went up to 87. And then I restarted it. So here you have how to do a button. Where is it? How to make a button. In this homework, we are also supposed to, let's see where it is. We are also supposed to make a program. Yeah, we are also supposed to design and code a program that shows the temperature on a terminal screen. My plan for this is to use the same. I've not been able to do this so far, but I have the program here. This is the ATC program. And my plan for this is to use the same method of blinking, so blink the temperature. I just have to blink 3 digits if it's going to be or 2 digits, yeah, whatever the temperature in Celsius. And my plan for this is to do the same thing, you know, set the LED as a output, blink a heartbeat, always blink a heartbeat so I know that the power on procedure went through well. And then I want to enable an input, but because the temperature, actually maybe I don't need to enable an input on this, but because the temperature is an analog signal, it's not just a high or a low. So we need the analog to digital converter. And I have not been able to make this work so far, so bear that in mind when I'm showing you this. But we know the analog to digital converter is here in chapter 33. And if we look, if you read this chapter, there's a bunch of information in here. And what I did find was that here in the where was it? Win controls, maybe. No, not here. Input controls. Yeah. Here in the input control. So in the input control register for the analog to digital converter, they have a multiplexed negative and a multiplexed positive. So you can connect a negative and a positive connection to the ADC, analog to digital converter. So here's the negative multiplexer input, and you can connect this to a pin or the ground. And so if you were to connect it to a pin, let's open another instance of this. If you were to connect it to a pin, you would have to look at here the multiplex signals in chapter 7 and check out what the ADC here. It's on peripheral B, so that means you have to see, here's the ADC, it's on ADC in 0, ADC in 1, ADC in 12, 13. So you know that these pins are connected this way. So if you wanted to connect pin on port A, pin 2 to the ADC 0, then you need to configure port A, pin 2 to peripheral B. And you do that in the port here, in the multiplexed signal. You just have to multiplex it for the correct pin, and then it's like odd even because it's pin 2. So you would modify the first 4 bits of that. I think I have this here. Yeah, here. Register bits right. Port A, multiplexed pins 2 and 3, and I multiplex from bit 0 and I do 4 bits and I turn it to 0x1, which is peripheral B function selected. And that is what we found here in chapter 7. Peripheral B is this ADC. Now, because the processor has a built-in temperature sensor, this is the negative. If you connect the negative to the internal ground, you should be able to connect the positive multiplex signal to the temperature sensor, which is here, temperature reference. That means you just have to set it to 0x hex 18. And I think I was doing it here. Set the negative to the internal ground and set the positive to the internal temperature sensor. And then I wanted to have because the ADC needs to be initialized. So far, I'm literally just saying enable the ADC, but I did find some more information in the datasheet about doing this and just run out of time with this homework. So I can blink the error here, see how it went to put it. It would actually make more sense to have this up here. And then I should initialize a temp variable. You should do it this way, just to have a temperature so that you can read something. But because I am still in the testing phase, I just set it to 21 degrees because 2 and 1 are two different numbers. So 21, 32 would be straight. So. And I cannot set it to 0, I set it to 25 actually. That would be easy to read also. No, 21. That way it's fast to load. You should be able to get this within a decimal, you should be able to get 21 point something, but if we start with a high one, that's just how it is. And then what you want to do is you want to start the conversion with this start conversion here. That's a software trigger that you need to use, and it says ADC start conversion. If you write 0, nothing will happen, but if you write 1, it will start the conversion. And then what you really want to do is you want to read the result from the result register as soon as the conversion is finished, immediately afterwards. So you really have to kind of wait for the result to be ready, and it would be smart to use interrupts here. That way your code could keep running and you don't have to wait for the ADC to finish converting. And then when it is finished, what I do is I want to do a short stroke to say, hey, there's a temperature reading coming, and then actually that should not be there. We should just take that out. So what you want to do, as soon as the results are ready, you want to read the results immediately. I'm having some issues with my bits read function. It's not working properly. I can read 1 bit just fine, but reading all of them is causing some issues for some reason. With the ADC, it is a 12-bit ADC, but you have 16 bits here, so you gotta make sure to read the correct ones. So you can get 16-bit resolution if you do some oversampling, but I'm keeping it super simple. Keep it super simple, so there's no oversampling currently going on, and that's why it's a 12-bit result. So what you want to do if you're doing that is to just keep it reading the first 12 bits. You can also have it shifted, and then you might want to read the upper 12 bits, but I have not shifted it, so it's just staying that. And then what I want to do is blink the temperature, and I was going to have it like this, but since I've made a new function since then, I would blink a 2-digit number, and then I would wait a bit. Here I was just trying to see if I could use a potentiometer to turn on an LED or not, and that was working. So I was commenting this out and then commenting this out. So just ignore this code, and that is how I would do that. If my code would work, I feel like this is pretty good, but there is something that is not working in this code here. In the button pressing, it was working. Now for the last one, I wanted to do a button press with the interrupt. So I've been looking a little bit into the interrupts here, and the interrupts are handled by the external interrupt control. Actually, they are handled by the, where is it? Right here, nested vector interrupt controller. This is what's controlling the interrupts, but because they have a lot of interrupts here, interrupt line mapping here, so the external interrupt controller can cause an interrupt. It has two ways of doing it. This NMI, what was it? Non-masked interrupt. I think so. The power manager, bunch of things can cause an interrupt to happen. So I want to use the external interrupt controller because I want a pin input to control when the counter for the button press is incremented. So we have the external interrupt controller here in chapter 21, and I read through it. There is here a functional description, so you can read how to initialize it and enable it. There is some stuff that you don't have to think about so much, like this clock. If you take a look at this clock in the generic clock controller, I don't remember, this is the top and Control F here. So this is in chapter 16, Power Manager, peripheral clock, default states here. So this clock is enabled by default, so you don't have to worry about it. You don't have to worry about it because it's enabled by default. So unless you disable it, then this doesn't matter. If edge detection filtering is required, so do you want to have it changing on the edge? Now I know that I just want to have it interrupt every time it becomes high. So I guess that would be a rising edge, but this is something I haven't figured out yet. So thank you very much. I hope this was good.